Good morning, students. In this video, we are going to discuss about heating effect of current. We all know that when a current flows through a conductor, heat is produced across it. This effect is known as heating effect of current. So let us consider a conductor AB of resistance R. When we connect this conductor through a battery of say V volts, it sends a current I in the conductor. That is, the battery maintains a steady current I across the conductor in the direction A to B. Now, if VA and VB is the potential of ends A and B, then VA must be greater than VB, and potential difference across its ends is V equal to VA minus VB, which must be greater than 0. Now if this current I flows through the conductor for time t, then the charge which flows from end A of the conductor to its end B is given as Q is equal to I into T. So this much amount of charge will flow from end A of the conductor to its end B when a current I flows through it for time t. Now, when the charge is at point A, how much potential energy it has? So potential energy of the charge at end A is charge into potential of that point, so Q into VA. Similarly, potential energy of the charge at end B, this will be charge into potential of end B. So change in potential energy when this charge flows from end A to B is equal to Q VB minus Q VA, final energy minus initial energy, Q into VA. So this is Q VB minus VA. This can be further written as minus Q VA minus VB, and this is your minus Q into V, which is less than 0. When this charge flows in the conductor without any collision, then its kinetic energy must also change so that total change in energy must be equal to 0 by principle of conservation of energy. That is, total energy remains conserved, meaning thereby change in potential energy plus change in kinetic energy is equal to 0. So delta U is equal to minus delta K is equal to minus delta U. Now delta K is equal to minus into minus QV, which is equal to QV that is greater than 0. That is, kinetic energy of electron would increase, but in our previous video we have discussed that free electrons moves with a constant velocity under the action of electric field, which is established due to potential difference maintained across its ends. That is, electrons are moving with a constant velocity known as drift velocity. So there is no change in the velocity. So where does this increase in kinetic energy goes? This increase in kinetic energy which electrons would have acquired in between two successive collisions is shared by the atoms ions with which they collide, as a result of which these atoms and ions start vibrating vigorously and appears as heat energy across it. So this is how the increase in kinetic energy appears as heat energy across the conductor. So amount of heat produced across the ends of the conductor when a current I flows through it for time t is given as H is equal to VIT, or we can write it in different forms by using the relation V is equal to I into R. So it becomes I into R into IT. So it becomes I square R into T. This is one more relation. This is one for heat produced. H is equal to I square R into T. So in place of I we can write V by R. So this becomes V square by R into T. So this heat produces V square by R into T. This is another formula for heating effect of current. So H is equal to I square R into T. This formula is known as Joule's law of heating effect. Joule's law of heating effect. Now power is defined as the rate at which energy is consumed. So power, we may write it VIT by T, so it becomes V into I, or P is equal to IR into I, so it becomes P is equal to I square R. Now P is equal to V square by R square into R. So it may also be written as V square by R. Now, loss of power in transmission of electrical energy. Electricity reaches our house using transmission wires, transmission cables, transmission wire. It has some fixed value of resistance, let it be RC. So if a current I flows through this wire, then amount of electrical energy which appears as heat energy across wire is given as I square RC. Now if P power is to be transmitted through the cable, then P is equal to V into I. So I is equal to P by V. So PC is equal to P square by V square into RC. So in order to derive power P, the amount of electrical energy which goes waste is given by this expression. From here you can see that the amount of electrical energy which goes waste varies inversely with the square of the potential difference across the ends of the wire at which it is transmitted. Meaning if higher is the value of B, the lower is the loss of energy. That is why electrical energy is being transmitted through transmission wires at very high voltage, 33,000 volts, so that minimum amount of electrical energy gets wasted during transmission of electrical power from power station to the points where it is distributed to different users. Thank you for watching.